The IoT is about connecting an infinite number of devices together to create data. It's about insights that allow decisions and actions to be made in a truly autonomous way. The possibilities are endless, challenging, and extremely exciting.
What is the Internet of Things? So it means different things to many people, but really, in simple terms, distributed technologies at a massive scale.
That's Ian Henderson.
My name is Ian Henderson. I'm a Chief Technologist for Hewlett-Packard Enterprise.
Along with Ian and today's guests, we'll be untangling the Internet of Things, from smart homes to manufacturing, via deep space communications, to discover what makes smart devices actually useful. Could telemetry make shipping more environmentally friendly? And is the IoT's efficiency ushering the fourth industrial revolution? All of this and a load more things. I'm Michael Bird, and this is Technology Untangled. The IoT is about connections and communications between the eloquently titled things.
A network of physical objects. That's what I see as things that are embedded with sensors and some software and other technologies for the purpose of connecting and exchanging data with other devices and systems over the internet.
Nitu Kaushal there, HPE General Manager for the UK and Ireland, covering compute, edge, IoT and digital services.
When we talk about things, I'm referring to possibly moving assets like cars or pallets, or even stationary things like machinery, equipment parts, or even buildings. It could literally be anything.
I think many people think of the Internet of Things in the smart home or a connected watch. I remember, I've done a lot of smart home things in my house over the years and ended up with over 100 different devices connected. But increasingly, we're seeing lots more in the way of connected sensors. So how do I understand what's happening in agriculture with sensors in the soil, or gathering data from different sorts of industrial devices where that data would just have been thrown away previously. So all different sorts of physical devices that are generating sensor data, usage data. We're looking at this being billions of connected devices generating huge amounts of data.
From smartwatches to cutting-edge agricultural soil sensors, the Internet of Things is about connected devices, sprawling networks, and massive amounts of data. So how do we get here? Well, it's time, as always, and I know you look forward to this as much as I do, for a little history. It
started from ARPANET back in the 60s of how do we start connecting machinery together? How do we send data from one location to another? And probably grew later on from that as connectivity became more pervasive to have the ability for additional connected sensors and a little bit more of intelligence in basic devices.
In the 80s and 90s, computer scientists were exploring the concept of adding sensors to objects in networks, but progress was slow. The technology wasn't really ready, the chips were way too big and bulky, and there was no real way for objects to communicate out to the internet, let alone to each other. What we now know as the IoT was really made possible by two innovations in 1995. The introduction of GSM data connectivity on mobile phones and the adoption of IPv6. Now, IPv6 provides so many IP addresses that we could give one to every atom on Earth. And then times that by 10.
IPv6, which has only recently rolled out at really massive scale, has given the ability to connect almost unlimited amounts of devices around the world. But where did that connectivity start to open up was probably, as we started to get mobile networks. So in the mid-90s, the first generation of mobile networks, which had elements of data connectivity.
In 1999, the phrase Internet of Things was coined by British tech pioneer Kevin Ashton, who then went on to create a global standard of radio frequency identification, or RFID. RFID are electronic tags with low power chips that can communicate wirelessly. Nowadays, they're used everywhere to replace barcodes.
The ability for those protocols to develop and the ability to gain value from that data grew as we went into late sort of 2009, 2010 with the M2M connectivity, so machine-to-machine connectivity beginning to drive that growth. But I think it's really exploded since the sort of smartphone revolution.
Back in 2008, when the first iPhone came out, a few megs of data each month would cost quite a bit of cash. But now you can get unlimited 4G and 5G data for only a few quid a month. And like a lot of today's cutting-edge tech, the advent of cloud also helped push the Internet of Things along.
I think the ability to build new applications on a cloud-based platform, right? So the barrier to entry has been massively reduced. That you can buy, a Raspberry Pi. I've got 4 or 5 at home doing various different things. If you think of the ability to buy what's actually a very powerful edge device like that as a connected device, add very low-cost smart sensors and things to it, build your own connectivity. It's really quite easy to get a new connected service out there today. Anybody can do that at home. Scaling it to industrial use is different, but very low barrier to entry in comparison with what it would have been just 10 or 15 years ago.
Where we used to be able to have one asset talking to a central platform in the means of machine to machine, what we're really seeing now is one asset talking to many other assets. And this is where the Internet of Things really grows. So IoT initially expanded by connecting high value assets and getting more out of them. Where the market is moving now, as we're able to connect to assets through whether it be Wi-Fi, Bluetooth, 5G, 4G, 3G, 2G, or even through narrowband IoT, technology innovation in the space of devices is hugely growing. And this is allowing businesses to connect much lower value assets.
5G is all about high speed and low latency. But not all things have the same requirements. And that is where narrowband IoT comes in. Technically, narrowband IoT is a 5G technology. It's a communication standard that can support a huge number of devices over a small spectrum of frequencies. And it's perfect for devices that need serious processing, network connectivity, or have battery life limitations. So think things like soil pH meters in remote areas or weather stations in inhospitable places.
2G was about voice. It was about simple audio dialogues. 3G was about browsing. 4G then moved up a gear and allowed consumers to share videos, which completely changed the way that we interacted on social media platforms. And where 5G moves into next is really going to be about business. It's all about those high value business applications that need very low latency and high throughput, but then engages with the consumers in a way that they've never been able to engage before.
Okay, history lesson over. So we've got all of our things and they're connected via the internet sharing data, and it's a whole lot cheaper than it used to be. IoT is a bit of a buzzword for so-called smart consumer devices, and some of them are just plain dumb. Looking at you, a Bluetooth electric toothbrush and Wi-Fi connected microwave. Seriously, what would you use them for?
Your pancakes are ready, sir.
Anyway, this is where things get tricky. What exactly constitutes our definition of IoT today? And when does it become really useful?
One of the customers that I've been talking to recently is a water utility, and they have what they call a SCADA network, so an industrial control network. And they might describe that as Internet of Things, but the reality is it's very much a status-based network with pre-programmed logic, in crude terms, a bit like if this, then that says, when this happens, open this valve. When you see that happen, close this valve. And they can see if a valve is open, and they get those updates maybe every few minutes, not real time. What they can't see is that the valve is open, but the water isn't flowing because there's a load of rags and rubbish blocking the pipe. So what they really want to do now is add additional sensor data so that they're looking to get real-time data of what's actually happening, right? And that's when it really becomes IoT for me. It's just not, I can see whether the light's turned on or not. It's, how much power is the light using? How do I add a few more sensors to help me understand what's going on? Not just that the pump is running, but actually what's the water pressure on either side of the pump? And if I can understand the water pressure on either side of the pump, I can tell probably how fast the water is flowing, which gives us a system of insight. So I have a better view of what's happening at the edge. The next level beyond that then is where I would turn that into a system of action. Right, we're going to connect some additional sensors. We'll almost wiretap some of the existing network. We will take that data and allow visualization to understand how things are operating. And then look at the way I operate today, use that data and modify the way I operate. But the point that we'd like to get to for that next level of efficiency is where it's closed loop, right? Where I'm taking the extra sensor data and I'm feeding back to an actuator. So I'm looking at how a pump is running and maybe changing the speed that it operates.
So it's not just a case of connectivity equals good. Benefiting from the IoT is all about the value of data.
The automotive industry, we know, is moving towards software-heavy cars. This allows cars to run updates over the air, have a much better driver experience within the car. So connecting the cars and then connecting the manufacturing plants provides a lot more clarity and better product into the market for the automotive industry.
Formula One teams, you could almost look at, they've invented IoT, right? So those vehicles have typically around 300 sensors on them, and they're looking at every single piece of that data. And that's a sort of bleeding edge, really good example of how connected that you can get, that they're actually predicting how many more laps they can get out of a set of tires based on all sorts of data. So I think that's leading edge, showing how you can exploit masses of data in real time and then change the way that you operate. The way that I see those guys taking that data and understanding exactly what's going on with the car and changing their strategy based on that in real time is probably the sort of pinnacle of how you get value from that data.
In the automotive industry, edge devices taking in massive amounts of data allow real-time tweaks to the car and its performance. As we mentioned on our previous episode on edge, there is a pendulum swing around where the data is processed. Compute at the edge is becoming more and more common as the things become more powerful and the data sets grow exponentially larger.
Where IoT is about connecting assets and collecting data from them, edge becomes the ability to process that information much closer to where the asset is, and then be able to provide near real-time action-led insights back into the business. Live video streaming all day long is capturing a lot of information, and if all these video streaming files are then processed in a central cloud, we introduce additional time needed to be able to analyze that data. That predictability that a business wants to introduce becomes a lot harder and slower. So if time is of the essence, then some of these applications need to be processed at the edge.
Being able to process data at the edge means the IoT can provide innovative ways to manage and monitor far-flung operations in remote places, constantly feeding information into applications and data stores.
So in the space of agritech, what's been really interesting here is whilst we are in remote spaces and connecting up some of these areas has always been a great difficulty, but with the rise of 5G and also low power wide area network narrowband IoT, the ability to connect these remote spaces and also connect low value assets has become a lot easier. With the ability of drones, we're now able to fertilize land remotely and have much better control and information of how some of these crops are progressing over time.
To hear a little more about remote monitoring at the edge, we called up Chris Roberts, the head of artificial intelligence and cloud at the Goonhilly Earth Station.
Goonhilly is effectively a telecommunications hub. Effectively, all of the satellites or birds that are flying around the sky, collating information, or if information is bouncing off them, that will either be emitted from, caught by, or a bit of both by Goonhilly. Then the information will be sent, let's say, from Goonhilly and will transmit via satellite to a location somewhere else on the globe. 50, 60 years ago, when Goonhilly came into life, all of the UK satellite traffic pretty much went through Goonhilly. So if you think of it as a sort of central hub, if you like, for all of the satellite comms in the UK.
Goonhilly sits on a 163-acre site, and looking at it, it looks super futuristic with all these big dishes, or aerials, as Chris calls them. And it's based near Land's End in sunny Cornwall, the westernmost point of England. And Goonhilly was one of 3 Earth stations in the world involved in the first transatlantic TV transmission in 1962. It beamed the moon landings to millions of viewers in 1969, and now, like many organisations, they're pretty interested in what's happening at the edge. The difference is, Goonhilly's edge is in space.
0, all engine running. Liftoff.
There's 2 primary functions, which are deep space and near space. Deep space is all about a commercial deep space network. So if you think about NASA, ESA, all these space agencies around the globe, some of the assets that they were using for deep space communications are decades old. And the idea really is to provide a better, more efficient network that can support the space transmission and communication requirements of lots of different countries. So near space is what we call anything that isn't deep space. So this is the low Earth orbit and geostationary stuff. You'd have heard of Elon Musk's company, SpaceX, Blue Origin, Jeff Bezos. And this is where they are building out, if you like, a space internet. With deep space, your target market, if you like, is space agencies. So there's a limited amount of those on the planet. So they're still quite large dishes. And the low Earth orbit satellites whiz around the Earth at very high speeds. So they need much more nimble, smaller antenna that can track these. We have both the deep space antenna and the low Earth orbit antenna at Goonhilly. And then we also use geostationary antenna as well. And these are all sitting at different orbits in the Earth.
There are lots of reasons why we'd want to take readings and monitor the Earth from space. Weather and navigation, Earth observation, telemetry and tracking, and even deep space communications. And all of this edge data is inspiring a host of previously unexplored use cases.
Edge, particularly for us, does lend itself towards things such as meteorological, so weather, shipping, so anything that requires the data to be acted upon quite quickly, or where people want to be able to process that data in close proximity to the antenna. Because of our proximity to the subsea cables, at Goonhilly in particular, we're almost like a springboard for 38 different countries. Data can come in from all over the world. And what we can do is take that and process that and potentially send that back out again without even touching the kind of core networks, which has got an extraordinary commercial application, if you think about it, reducing the cost of that data. I mean, Earth data, although it's a very sort of catch-all term, but the applications are extraordinary. If you look at coastal erosion and flooding, so if you think of insurance companies, one of the biggest challenges for consumers at the moment who are buying their insurance. So if you're in postcode GU11 in Guildford, near Guildford, I only say that because I used to live there, you might be half a mile away from another guy who is living in a basin that gets flooded every year, and you're absolutely fine, thank you. But because they can't be as accurate normally in order to calculate premiums. So using Earth observation technology to sort of look at the patterns of flooding, you can be much more accurate about that and start to build up a real picture. That's collating data and storing that at the edge.
What makes Goonhilly so exciting is the way this edge data can be used to make decisions and potentially change industries.
I think that's going to happen as the data volumes increase and the possibility of autonomous communication between things like self-piloting ships. There's a vast amount of money going into, the digital marine marketplace in order to improve things like the environmental cost of moving tons of stuff around. So all the stuff that we order from China, from Wish or whatever, has an environmental cost or a carbon cost. So, you can do things like track the telemetry of ships. Then, if a ship's got space, if a ship's low in the water, it's carrying a lot of cargo. If it's high in the water, it's probably not carrying anything. We're already working with a couple of companies who are looking at tracking satellite data, tracking telemetry on ships for a number of different reasons. But potentially you could say, right, I'll look at all of the ships around the world, look at what their unladen status is and their laden status. And you might say, well, we reckon that you could fit 40% more cargo in that ship without it being overladen. So there's lots of, different use cases for this. And if you can start to almost point vessels or devices and make them more efficient, you do that by processing that at the edge.
Now, if coastal erosion or streamlining shipping operations isn't really your wheelhouse, don't worry. As Ian explains, the IoT is all about driving efficiency in just about any industry.
A lot of the time, working with the larger organizations, there tends to be three things they're trying to do. Right? So one is reduce operational cost. So a lot of that is looking at overall equipment efficiency. So understanding if I've got machinery running in a location, is it running as efficiently as it could? Can I compare that to a different similar facility that I have somewhere else in the world and understand why one of them is more efficient than the other? Bigger one probably is how do you improve the customer or the employee experience? Things like location-based services. So the ability to guide a customer or an employee around a facility using Bluetooth, the ability to understand how many devices are in a location and how they're working, those sorts of use cases. And then as we go into the more extreme analytics at the edge, which is certainly where we're spending a lot of time looking at, what are those use cases? So video analytics, particularly in markets like retail, how do they give a different experience when a customer comes to the store? And a lot of that's around frictionless. How do the Amazon Go example, where I can walk into a store, it recognizes me as I walk in, I walk around and pick up my items and walk out, and it automatically bills my account. How do I do that whilst not risking increased shrinkage, as they call it, so theft or mis-scanning of components?
Analytics at the edge is the hot topic in IoT at the moment. And Nitu thinks we're going to be seeing a whole lot more of it in the post-COVID world.
We are seeing other emerging use cases for IoT, and some of these have been driven by the pandemic itself. So thinking about existing CCTV footage that buildings and businesses have been capturing for years, thinking about how that could then be used as a safety mechanism in airports and in train stations, that live streaming video, measuring people temperatures, sharing that video back to a control point that will then analyze the safety of the crowds, and then being able to then use that information to encourage better safety procedures and control points within areas is going to be a big area. And this really shows that a lot of data is going to need to be processed at the edge because you're going to require rapid decisions.
Organisations approaching the IoT will need to consider how they deal with data, both from an analytical and organisational point of view.
So a good example was a European automotive manufacturer, and they had different simulations of data being run by the powertrain team, the chassis team, the noise, vibration and harshness team. And when we looked at the data, some of the simulations that were being run by the noise, vibration and harshness team had already been run by the chassis or the powertrain team earlier on in the process. Right? So the different teams describe the data differently, and they don't share it. And this was actually one of the questions from the motorsport team that I mentioned that we work with, where they said, we know the answers to everything, but we don't know what we don't know. But I think that's the value here of the interconnected thing is the value of the data. And that needs to be shared and visible across the whole organization. So that's the challenge, not just generating more and more data, but getting value and visibility of that value.
The way businesses are handling all this additional information from the devices and more devices that are going to be added into the network over a period of time is one way they're looking at near real-time data that can help them drive some near real-time business actions. The other way is looking at things in a more data at rest perspective, from a data lake, a big data perspective, using these insights to build trends over a longer period of time that can help businesses really understand how they are operating, but also what their customers need.
One of the challenges I see in IoT is what we call proof of concept purgatory. How do we build the business case for these things? Lots of people have very smart ideas about what they could do. They'll take a piece of relatively low-cost hardware like Arduino or Raspberry Pi and show a simple model of how they can get the IoT data that they want. But it never gets to that point of scaling out to be real-life production use. But it's really about the value of data through the full life cycle of the product. Right? Taking data from the connected products and feeding that back into the development and continuous improvement of the design. You can look at it with Tesla, the vehicle you buy is not a finished product. It can change and be upgraded over time. But to build some of those solutions, it's very hard to get the business case over the line, right? Because you're saying, I want a really big investment to do all this huge project. And I've not really proven that the business case is going to return the investment that I make. So the way that I work with customers is trying to define, right, where's that nirvana that we want to get to? But how do I break that down into a series of small sprints? How do I do a 6 or 8 week project which shows I can return the data and the value that I want, with the second step of then saying, right, now we're going to scale it out across the next 6 or 8 weeks to another 10 locations, and the business case gets built stronger and stronger as you move through each element of the use case.
Although the IoT has a lot of potential, in many ways it's still a maturing innovation.
Machine to machine has been around for over 10 years already. But if we look at the grand scheme of things, we probably haven't connected even 5% of all the devices that could possibly connect in the world. So there's plenty of space to move into. And new technologies like 5G and narrowband IoT are going to enable the connections of that remaining 95% of devices. So in that sense, you could think that it's still a new industry, it's a new technology, but the understanding of IoT has definitely matured, and the ability to integrate IoT into your home is also an ongoing trend in urban areas.
Industry has done a lot of the legwork in the IoT story, and they're pinning their hopes on, buzzword alert, Industry 4.0, known as potentially the next industrial revolution.
I think we've got a long way to go. Next 10 years in IoT, I think, is going to be amazing. If I look into manufacturing, they haven't really started yet. So you'll hear this term Industry 4.0. We went from steam to electricity and to automation were the first three. And the other way we describe the fourth industrial revolution is moving from automation to autonomous. Autonomous is that closed loop of data management. Automation, which we have today, will do the same thing consistently. And if it drifts out of tolerance and goes wrong, it will just produce something consistently wrong. Right? I used to get companies would talk, we've got ISO 11,000, is it? We're a quality company. Well, it doesn't mean you're making a quality product. It just means you're making it the same way every time and you can prove it. So the ability to move from automation to autonomous development and self-tuning is what Industry 4.0 is about. The challenge at the moment is we haven't even really started getting the value from the data that we can collect. So I think it's going to be really fascinating.
So what do organisations need to develop in order to use the IoT, make the most of the data they're producing, and aim for that closed loop management?
In a lot of these spaces, there's a healthy skepticism and concern about the security risk, right? And that's good because there is definitely a risk that needs to be considered and addressed as you go into it. So I think looking at that and making that more mainstream. I think one of the challenges as we roll these out is how do I manage all of those devices? It's not too difficult to take a Raspberry Pi or an NVIDIA Jetson and show how I can do some really powerful analytics at the edge of the network. But how do I do the lifecycle management of it to do firmware updates, application updates? And those are challenges that we've learned in the data center over the last 20 years. When we sell a high-performance compute system with literally thousands or tens of thousands of cores, the ability to understand the health and manage that. So that's where we're investing a lot of time looking at how do I manage the security and life cycle of firmware and applications across potentially thousands or tens of thousands of connected endpoints all around the world. And I think that's the level of maturity that we need to get to.
A robust security architecture for devices and edge networks is absolutely paramount for organisations, and you can find out more about that in our previous episode on Edge. For Nitu, the proliferation of 5G is going to be vital to help smaller organisations advance too.
The network providers play a really strong role in, firstly, rolling out new technology as a backbone to enable more connected devices, but then also how you can access some of these frequencies a lot more easily to drive innovation locally within different countries also becomes important. So we've seen in the US, for example, in September 2019, some of the operators have made frequencies for free so that businesses can drive net new innovation. And this is helping smaller businesses accelerate.
There's already way more things connected to the internet than people. So what on earth is the IoT going to look like in 10 years' time?
If I cast myself back 10 years and think of what IoT was, and I was a hobbyist playing with home automation. I was using a thing called X10, which used signals over power lines to turn lights on and off and have some logic into the way that my house worked. And it was very much bleeding edge, hobbyist technology, not very reliable, quite expensive. If I look at the house now, everybody's got Hue light bulbs, Hive heating, it's mainstream. So I think if we look forward 10 years, these things will just be ubiquitous. We will just assume this visibility of data and the ability to interact with our world in that digital way is just natural.
You've been listening to Technology Untangled, and a big thanks to today's guests, Ian Henderson, Nitu Kaushal and Chris Roberts. And you can, of course, find out about today's episode in the show notes, and be sure to hit subscribe in your podcast app and join us next time when we'll be charting the murky waters of digital ethics, artificial intelligence, big data, and the challenge of our generation. Today's episode was written and produced by Isabel Pollard and hosted by me, Michael Bird, with sound design and editing by Alex Bennett and production support from Harry Morton and Alex Podmore. Technology Untangled is a Lower Street production for Hewlett-Packard Enterprise in the UK and Ireland. Thank you so much for tuning in, and we'll see you next time.